To look at the circulation changes, we go back to our monsoonal circulation. We had looked at just the Indian summer monsoon and Australian summer monsoon in terms of some rainfall averaged over those regions, and we had looked at long-term variabilities. We argued there were some multi-decadal variabilities, and the Indian monsoon has a very low interannual variability of only about 10%. Australian and other monsoons have larger variabilities. We had talked about the Asian monsoon gyre and its impact on large-scale circulation in terms of this PV advection around it, the easterly jets, impact on the West African monsoon, and so on and so forth. To define a good circulation index, it's often been now called a global monsoon, where the mean of JJA minus DJF precipitation and the vertical shear as well, V850 minus V200 between the two seasons is seen. So shown here is the Northern Hemisphere Monsoon System, NHMS, climatological mean JJA minus DJF rainfall in colors, and vertical wind shear vectors, 850 hectopascal winds minus 200 hectopascal winds. Remember the Webster-Yang index, for example. Monsoon rainfall domain is identified by the summer monsoon minus winter precipitation rate exceeding 2 millimeter per day, and the local summer rainfall exceeding 55% of the total annual rainfall. So this is the definition, that there is a significant change from the summer to the winter, and majority of the rain, at least 55% of the annual rain, falls in the local summer. Okay, so the area boxed the over 0 to 20 north, 120 west to 120 east indicates the region where northern hemisphere monsoon vertical shear is defined. Okay, this is as opposed to just the monsoon index we had done before. Now we have a global monsoon vertical shear index as an indicator of the, let's say, strength of the hydrologic cycle. Okay, so I will come back to this in a minute. So if we look at the variability and trends of northern hemisphere monsoon system, you can see that variability and trends of the NHSM system, the Hadley circulation and the Walker circulation. So if you increase the monsoon circulation, then you expect an impact on the Walker cell as well as the Hadley cell. That would mean the intensification of the entire circulation system, which is now moving us from the SST changes and warm pool changes to the column heating changes and convection change to the circulation change. Obviously, moisture convergence and subsidence, zonal and meridional circulations are all part of the changes in convective heating, of course, right? So this is again northern hemisphere monsoon rainfall rate defined before, averaged over the entire northern hemisphere monsoon domain. Vertical shear of the zonal wind we have seen before, and the northern summer Hadley circulation intensity measured by maximum absolute value of the mean meridional stream function. So you basically look at the cross equatorial flow and you get a sense of the Hadley cell strength. Walker circulation intensity is measured by the vertical shear of the zonal winds, 850 minus 200, averaged over the equatorial Pacific region given here. Okay, this is data from the Global Precipitation Climatology Project and the ERA interim reanalysis. So you can see that there is a clear increase with the variability around it in the NHSM precipitation. There is a vertical wind shear has gotten stronger, which corresponds to the increase, and remember the aquaplanet experiment as well, as SSTs were increased, vertical motion increased, and then vertical shear increased at the edges of the warm pools and convection as well. Boreal summer Hadley circulation has gotten stronger. There are other debates about whether the Hadley cell is actually expanding in its latitudinal extent. That's a slightly different but very closely related debate. Boreal summer Walker circulation also has strengthened. As you can see, the vertical shear has gotten stronger. The big debate here is really about the idea of what should happen as global warming happens or global mean temperatures go up. The original ideas of Isaac Hell, Brian Soden, Gabe Vecchi, and all were that a warmer atmosphere will hold more moisture, and the moisture increases by about 7% for each degree warming, and the rainfall only increases by about 2 to 3% based on observations. And the idea of explaining that was that when the background moisture is increased, the vertical fluxes don't need to be as rigorous to create the rainfall, and hence the Walker circulation would slow down, and the Hadley circulation will correspondingly respond. But this result is very different. This is saying that in fact both have intensified along with the northern hemisphere summer. So the trends here again are discussed May through September, MJJS, so May, June, July, August, September precipitation and circulation indices, in addition to the Hadley and Walker intensities and the mega ENSO index. We will see what that is in a minute. So if you look at the period of 1979 to 2011, precipitation has increased, threshold temperature and the these are just the significance tests, never mind. Circulation intensity has increased, a very significant trend. Hadley intensity, Walker intensity, and the mega ENSO index. Mega ENSO index is related to a definition which we will look at in a minute. I will leave this here and return this to this in the next podcast. Just remember that northern hemisphere summer monsoon has increased. Hadley index has increased. Walker index as the vertical shear also has strengthened. Okay.